Welcome back to Section 5, Lesson 1, Video 2. Here we're going to continue to use elimination to solve systems of linear equations. Now in this video, we're going to look at solving systems of equations that have fractions. So we're going to start with the same step as when we were solving systems that have fractions using substitution, which was to get rid of any fractions by multiplying by the lowest common denominator. So in the system in A, we have x plus 2y equals 7 and x plus a eighth y equals negative a half. So the first equation don't have any fractions, but in the second equation, I see 1 over 8 and negative 1 over 2. So the common denominator here would be 8. So we're going to multiply the whole equation by 8. So let me write an 8 next to each term and then simplify. So we would start with 8x, then the 8's would cancel, and negative a half times 8 is negative 4, leaving us with this equation here. Now let me write the first equation underneath. Now let's solve the system using elimination. So you can choose to eliminate x or y. If you choose to eliminate x, you can multiply the second equation by 8 to make the coefficients of x the same number. Or if you want to eliminate y, you can just multiply the top equation by 2, which is what I'm going to do. So if I multiply everything by 2 in that equation, I would get 16x plus 2y equals negative 8. And again, rewriting the second equation underneath and lining it up, I can now just subtract these two equations. So now when I subtract, I would have 16x minus x, which is 15x. 2y minus 2y cancels. And then negative 8 minus 7 is negative 15. So now to solve for x, we can divide both sides by 15, which would give you an x value of negative 1. So now to find y, we can plug this into the first or second equation. I'm just going to plug it in right here. So that would give me negative 1 plus 2y equals 7. Now to solve for y, I need to isolate it by bringing the negative 1 over to the other side. When I add it with 7, I get 8. Now I need to divide both sides by 2. So now I get a y value of 4. So let's write our solution as negative 1, 4. And if you would like to verify that, you can replace x with negative 1 and y with 4 into both equations. Now let's look at b. For the first equation, I see we have 12, 4, and 4 in the denominators. So I can multiply that whole equation by 12 to get rid of the fractions. And for the second equation, I only have a third, so I can multiply that one by 3. So now if I multiply each term by 12, the 12's will cancel, giving me 5x to start. Now 12 divided by 4 is 3, so then I have 3y, and a quarter of 12 is 3. Now let's look at the second equation. The 3's will cancel, giving you just x. And then y times 3 is 3y, and then that would equal negative 9. So now you may notice that the coefficients of y are the same. So we can just go ahead and subtract these two equations to eliminate y. So 5x take away x is 4x, and then 3y take away 3y is 0. Now 3 take away negative 9 is going to give you a positive 12. Now I can divide both sides by 4, which means x equals 3. So now let's replace x with 3 right here. When I do that, I get 3 plus 3y equals negative 9. Now let me bring the 3 over to the right-hand side, making it negative 3. When I simplify that, I get 3y equals negative 12. Dividing by 3 now will give me a y value of negative 4. So our solution is 3, negative 4. Now let's look at one more example. For the first equation, I see that the LCD here is 6. And for the second equation, between 4, 5, and 4, the LCD is 20. So now let me put a 6 by each term. Now a half times 6 is 3. A third times 6 is 2. And on the end, the 6's cancel, leaving you with negative 1. Now for the second equation, a quarter of 20 is 5, so you'd have 5x. Now to multiply 2/5 by 20, you can see how many times 5 goes into 20, which is 4. And then multiply that by 2, which will give you 8y. And then 11 over 4 times 20 is 55. You can work each one out by hand, or you can use a calculator if you like. So now you can see this system is much easier to work with now that we got rid of the fractions. So now we can easily eliminate y. I chose y because I just need to multiply the first equation by 4 to make it 8. You could eliminate x, which means you'd have to multiply the top equation by 5 and the bottom equation by 3. So multiplying one equation is just one less step. So now if I multiply that by 4, I get 12x plus 8y equals negative 4. And I'll write the other equation underneath. Now I can eliminate the y variable by just adding the two equations together. 12x plus 5x is 17x. The y's cancel. And now negative 4 plus 55 is 51. Now I'm going to divide both sides by 17, which gives me x to be 3. Now you can replace x with 3 in the first or second equation. I'm just going to use the first equation and write 3 times 3 plus 2y equals negative 1. Now 3 times 3 is 9. Bringing that over to the right-hand side and subtracting it from negative 1 would leave me with 2y equals negative 10. Now I can divide both sides by 2, giving me a y value of negative 5. So I'll write our solution as 3, negative 5. So that's how you can work with systems of equations that have fractions. You can now move on to the next video in this lesson.